All right. Hey there, checking my hair here as I come to you on video today to make sure you have a great start to what we call division of monomials, which opposite of multiplying monomials, and you're going to see some of that in our work, and we're going to take our time. We're going to do thorough work, so please remember what you see me doing and what I'm advising you to do is what you should be doing to help yourself develop good habits and a good understanding of division of monomials. So let's first, before we get there, go ahead and take a little time here to do a warm-up. As you can see, we have the quantity of -9, x squared, y cubed, z times 4x to the 5th, y to the 3rd, z to the 3rd power. So feel free to pause me, and then after you unpause me, I will reveal the answers. So pause me now. All right, as you can see, I used the different colors to help us. -9 times 4 is -36. X squared and x to the 5th make a grand total of 7 x's being multiplied to get x to the 7th. Here we have y to the 6th and z to the 4th power. So if you need to, if you're struggling with that, do expanded notation. If you're struggling with that, ask someone near you, hey, can you explain it? I'm not sure where y to the 3rd power came from. But hopefully you're like, got that. Hopefully you're realizing what the shortcut is. I'm not going to tell you, but I hope you're realizing what the shortcut is when you are multiplying monomials. Now, we're going to start by simplifying monomials. So I'm going to let you take a look. I'm not showing you these examples, but I'm going to let you take a look. Pause me, and in a moment, unpause me, and I'll reveal what we're going to be doing. So pause me now. All right, so what we really need to be doing here, ladies and gentlemen, is what you see here on the screen is we need to be simplifying using giant ones. And if you were here last year at Hershey Middle School, you understand that a giant one is like 2 over 2 because it makes 1. Or -8 divided by -8 makes 1. Or can you think of one on your own? 12 over 12 makes 1. So here, 10 divided by 15 doesn't make 1. But if I think about, well, what factor, what number, that's what a factor is, divides into 10 and 15? Well, 5 divides into both numbers, so 5 times 2 makes 10. 5 times 3 makes 15. And here, and this is the heart of division of monomials, is here we are going to divide the 5 and the 5 to make 1. We cannot divide the 2 and the 3. And when we simplify 10 divided by 3, or excuse me, 10 divided by 15, we get 2/3. And you might be going, well, that's easy. Well, this is going to lead us into a bigger idea where we're going to be making giant ones with variables. So take a moment and try the next 2 examples. Pause me now. Or if you're like, I still need some help, watch me do the next one. So I'm going to move this guy out of here. And here for the next one, I have 12 divided by 21. 3 divides into both 12 and 21. And so I rewrite 12 as 3 times 4. I rewrite 21 as 3 times 7. I simplify the 3 and the 3 to make 1 to give me 4 over 7. Is that simplified version. And now for the next one, we got to think about, well, what if I have x to the 4th power divided by x to the cube power? It is some number, the same number, taken to the 4th power in the numerator, and some number in the denominator, same thing as the numerator, taken to the 3rd power. So we can rewrite that as x, or 4 x's being multiplied, and I'm going to move me here, and 3 x's being multiplied in the denominator. You might be like, well, why are they crossed out? Because like we saw in example 1, we want to make giant ones. So here is a pair of giant ones. here's a pair of giant ones, and here is a pair of giant ones, because x divided x makes 1. Could be a negative 3 over 3, negative 3 over negative 3, could be a negative 7 over negative 7, but whatever it is, it's the same number over itself, leaving us with just good old x over 1, or really simplified, leaves us with x. So hopefully now you're seeing, all right, so when we divide monomials, we need to make giant ones, simplify them, and write them in a simpler version. So take a moment. If you haven't written this down, write this in your notes. Take a moment, maybe talk with somebody at your table quietly, and then resume me when you're all set to go. All right, so we are going to skip this next slide that you're seeing right now. I think we're in good shape here. I think I showed you the work. I think I went over it. So I think we're in a good place. But keep in mind, we're trying to do anything like y divided by y would make 1. If I had z over what would make 1? Well, hopefully you realize z divided by z would make 1. And I put that little horizontal line to make sure you know it's a z and not a 2. Now, go ahead, take a look at the next slide, see what you can do with it, rewriting division or rewriting our problems as multiplication so we can make giant ones. So take a look, pause me now, and then resume me in a moment after you take a look and do what you can with the next slide. All right, so I'm back. I'm on the next slide here, and hopefully you are feeling good about this new giant 1 idea to help us simplify. So x to the 4th divided by x squared, we would have a pair of x's in common in the numerator and the denominator to make 1. We'd have a pair of x's in the numerator and denominator again, but then we're going to have 2 left over to make 1x squared. Since we have a 1 in the denominator, our final answer is x squared. So think about that. Think about why that works out that way, and hopefully things are starting to make sense. We won't always need to write things out into this expanded notation and make ones, but because we're new at this, and you want to have a good understanding, it is wise to do. So let's take a look at my next example. I'm having trouble moving my window. Okay, there we go. I got it. Here now we have m to the 8th power divided by m to the 3rd power. So that can be rewritten here as 8m's being multiplied in the numerator, a lot to write out, and we only have 3m's in the denominator. As we make some giant ones with 3 different pairs of m's in both, we're left with m to the 5th power. Hopefully you see it simplifies to that. And at this point, I'm noticing we're always having variables left in the numerator. That's not always going to be the case. So let me just show you to the side here at the top. What if I have something like y cubed over or divided by y to the 5th power? Okay. If I have something like this, I'm going to have 3 y's in the numerator to give me y cubed. And how many y's would I have in the denominator? I would have 5. Just writing it out quick here. Hopefully you are too. Maybe you're pausing me or you're writing it down. And then to make some ones, let's use a different color. To make some ones, I have 3 in common in both the numerator and the denominator. I make those ones. And here I can see I'm left with 1 in the numerator, but 2 y's in the denominator to make 1 over y squared. So I hope you see, hey, yeah, we're not always going to be left with variables in the numerator. Here's an example of variables left in the denominator. So I am going to let you go about your business, do a couple more examples. Here you have a few more examples here and a little bit more with difficulty. So do as many as you can. Tomorrow, Mrs. Kakura will be in and she will help you as well. But you are hopefully in a good place. You're starting to make some giant ones. You're making sure you're being diligent about crossing it off and making ones. And hey, do some good work. Make yourself proud of yourself. All right. I'll see you around. Bye-bye.